planet Earth. If you look closer, you'll see that a whole other world exists beneath the surface of land and sea. Layer after layer of rock structures that go deep into the Earth's crust, mile after mile. And trapped within these structures, along with other liquids and solids, you'll often find deposits of oil and natural gas, the world's two most important sources of, you guessed it, energy. These famous fuels are in constant demand because they make the world go round, day in and day out. So, how do you go about finding something that's completely hidden beneath the Earth's surface? It's a mystery that people in the oil and gas industry are always trying to solve, and for very good reason. Drilling for oil is expensive, and before they spend money on equipment and crews, exploration and production companies need a reliable strategy for pinpointing where to drill. Thankfully, they have a secret weapon. You might say it's an earth-shaking innovation.
Hello, hey. Still in here, Doc.
It's called seismic exploration, and it involves sending shock waves or wavelets into the ground to get a sound picture of the Earth. And I just happen to know where one of these wavelets is hiding.
Hello?
Hey, Wally.
Hey, what's shaking, pal?
Well, you for one.
Indeed.
May I introduce Wally the Wavelet, our seismic expert.
In the flesh.
Hey, Wally, I was hoping you could help me tell the story of seismic to our friends out there.
No problem. Let's start with bats.
Bats? Why bats?
Allow me to illustrate. You see, bats can't see very well, so they send out little waves of sound that bounce off of objects and then go back to their ears. It's called sonar. This keeps them from flying into the wall of a cave. It gives them what you might call a sound picture of their world.
Well, that's a good example of how nature already uses a form of seismic technology to locate objects. But people who are trying to locate oil and gas inside the Earth do it a little differently, right, Wally?
I'll say. You see, geologists use man-made tools to make the sound wavelets, listen to them, and then record them.
Well, I say we just take everyone along on a seismic shoot. You ready to lead the tour, Wally?
Well, I thought you'd never ask. I'm out of here, pal. When you want to know if oil and gas deposits are in a particular area, they bring these large trucks that have big vibrators on them. This is what generates the noise or vibration. You also have to have something to hear the sounds. These are called geophones. They're like big seismic microphones. They set several of these out on the ground in a line. These microphones are attached to a recorder inside another truck. Here's where I have my starring role. They start up the big vibrators, and that sends me, a wavelet, and lots of my wavelet buddies cruising down into all the different layers of the Earth. I bounce off the boundaries between the rocks beneath the surface and get reflected back to the geophones that are waiting to record my arrival time. Hello? Each geophone along the cable sends me to the recording truck where a machine records my movement onto a magnetic recording tape.
Well, what about out in the ocean? How do you wavelets get down into the subsurface to do your work? There's a lot of water out there. And how does it all get recorded?
Glad you asked. That's what you call offshore seismic. We just require a different device to get us going and to record our movement. Let's check it out. Out at sea, a seismic crew works off a boat with a specially designed back end. It's sort of chopped off so it's easier for them to lay out floating cables. And all along the length of these cables, microphones called hydrophones are attached one after another. Several of these hydrophone cables, or streamers, are pulled behind the ship at once. These air guns are laid out several meters beneath the hydrophones in a special pattern. Then, pow! They shoot out a burst of compressed air. We wavelets swim through the water and into the subsurface below, where, just like on land, we bounce off the geologic structures and then head on up to the hydrophones for a recording session. Hello?
Now, Wally just described two-dimensional, or 2D, seismic. Oil and gas explorers also use three-dimensional seismic surveys.
That's right. 3D surveys give you a more detailed picture of what's beneath the surface.
It's kind of like the difference between this and this.
Want to know how they do it?
You're the expert.
On land, 3D seismic is created by shooting a 2D one direction and then shooting another 2D that crosses the same area in another direction. This creates a grid that looks like a seismic cube and shows volume.
Now, as you'd expect, 3D takes a lot more time and money.
True, but it means you get a much better picture of what's going on underground.
And it means less chance of drilling a dry hole.
Bingo!
Now here's what seismic looks like after it's been recorded and printed.
It looks like a bunch of squiggles at this point.
There's still a few more steps to go before it begins to look like an actual picture of the inside of the Earth.
Right now the data is still in its raw form. To get a picture that actually looks like the Earth beneath us, the data has to be processed. Check this out. It takes a large PC cluster like this to process the seismic data. The computer goes through all of the different traces made by the wavelets and filters out all of the stuff we don't need, like the vibrations made by a tractor in a field nearby. Then, just the good wavelet traces are combined to give a better picture.
Okay, now we've gone from this to this. But you're probably saying, that still doesn't look like much of a geologic structure. But believe it or not, geoscientists can look at this processed data and make a decision about why or why not to drill.
Or they can use some really amazing computer applications. Working on state-of-the-art workstations, geoscientists can see the seismic data translated into a 3D picture. They can look at this with their trained eyes and actually make an informed decision as to whether or not oil and gas deposits are in the geologic structures.
So, now we started out with this and ended up with this. And none of it could have happened without Wally and his seismic pals. You guys really work hard.
Yep, we wavelets are behind the biggest decisions in the oil and gas business, buddy.
To drill or not to drill.
You got it.
You know, thanks to our friend Wally and his wavelet pals, seismic data leads to a high percentage of drilling success. And in a world where the demand for oil and gas is increasing faster than the supply, good seismic information will lead to greater production. And that's what SciTel is all about. Designing good seismic chutes, processing that data really well, and using years of experience to interpret that information.
I only work with the best.
Right back at you, buddy.
Wavelets rule!